Okay, so I'm going to do question 8 from the Undetermined Coefficients worksheet. I'm going to do it with long division first. Okay, now we have every term below the highest power, so we can go straight into it. X squared into x cubed is x, and then multiply it back. X cubed plus a x squared plus b x. Okay, and then change the sign and add vertically. Okay, here I've got q minus a x squared, and then plus or minus b x. And that's the 4-step process done. So bring down your next term and go again. Okay, step 1, first term into first term, answer on top. And x squared into q minus a x squared is q minus a. And multiply it back. Q minus a x squared plus, okay, I'm just going to go over here. We're doing ax times q minus a. So that's aqx minus a squared x plus and x, and then what I'm left with here is aq minus a squared, and then I'll pop that over here. aq minus a squared x. Okay, now this times this is plus, and I'm just going to pop it in a bracket to keep the structure. bq minus ab. Okay, structure meaning constants column, x column, x squareds column, and x cubes column. Okay, now you don't have to pull this over there, but I find it helps to get it in the form that we want it in, and change the sign of everything. Okay, now these two things here have to add together to give us 0, and these two things here have to add together to give us 0. Why? Because we were told that this here is a factor of that cubic, and when you divide a factor into the thing that it's a factor of, the remainder is always 0. Okay, now I know I'm finished, because when we divide a quadratic into a cubic, we find one other linear factor. Linear factor meaning an x term and a constant. So we have to be done. Therefore, these have to add to give us 0. Okay, now the x coefficients here, or minus b. Be careful here with this minus bracket. aq minus a squared, and that bracket is really important because it makes sure that you catch everything you need here with that minus. Okay, and then the constants part of this, s minus, again bracket, bq minus ab, and they're also equal to 0. All I'm going to do at this point is get rid of these brackets and tidy it up. So or minus b minus aq plus a squared equals 0. S minus bq plus ab equals 0. I'm going to stop here and look back to the question. What they've asked us to do is prove that or minus b, okay, hang on, I have an or minus b here, great, is equal to a times q minus a. Okay, I want an or minus b, so I'm going to leave that or minus b on the left hand side of this equation, and I'm going to throw everything else over here. Okay, what do we get then? We get aq minus a squared. Okay, I have an R minus B on the left and I have two terms on the right and they've got A's and Q's in them, so I'm pretty close to what they're looking for. However, they have A times. So let's pull A out of this. We get Q minus A and bang. There it is. That's what they wanted. Okay, now the other thing that they wanted was S equals. Okay, and I have an S here. B times Q minus A. Okay, now, Q and A, great, but we don't want that B there. So let's just write this as S equals first of all. So S equals BQ minus AB. Okay, the problem is they're looking for an equation with S, B, and Q. Oh, hang on, this is the same. It's just as easy as the other one. If I pull out B, I get Q minus A. Okay, yeah, we didn't want to be in two places, we only want it in once. And again, that's that. Done.